Hi there, folks. So I got a question here. It's to do with it's a bit like geometry. So I'm just going to quickly run through it and just how you go about doing it. Okay. So you're asked here to find the angle CAD. So if we were to join up, if we were to do this here as follows, right? If we were to make two lines like that, right? So basically you're asked to get this angle here. So that we're looking to get. Now, when I see that angle there, because it tells us as follows, that the radius of the circle is 4. So that's 4 and that's 4. It also tells us that this distance here between them is 6. Okay? So if that AB is 6, that would mean, if I drew a line down here, that this here would be 3. Okay? So what I'm looking at doing here is, I want to get the length of CD. Because if I get the length of CD, then I can use the cosine rule. Because I've got 4 in the length of CD. Now, that comes straight in there, so that's a right angle. So, if that's from here to here is 3, and that's 4, I have a triangle like this. 4 and 3. So I can use Pythagoras' theorem, call that x. So x squared plus 3 squared is 4 squared. I can work out what x is, double it, then I'll have the length of CD. And then you just do the cosine rule. So, which would be a squared is equal to b squared plus c squared minus 2bc cos a. So in this case here, a would be equal to cd, whatever you get for x here. B is 4, c is 4, you work it out. That allows you to get cosine a, and you can work out a there by getting the inverse. So that allows you, that's how you do that part there. Now, the other part there is hence find the area of the shaded region, correct to one decimal place. Okay. So, if I want to get the area of the shaded region, now, you have to imagine here that you've got one circle. So, what I can do is as follows. If I was to go and get, now I'm just going to rub this out here just to show you, to make this clear. Right, so we rub that bit out there now. And I want to, okay, now, I'm going to rub this out as well. We just leave it, that was A there. Okay, now, if I put my lines back in here, right, I'd have angle A from the first part. So that means I can get the area of the sector, which is the area of all this here. Because I can just use the area of a circle, pi r squared, multiplied by whatever the angle A is, over 360. But what I want to do is, I can also then get the area of the triangle. It's going to be the yellow bit. So if I get the area of the triangle, I can then take that away from the area of the sector, which gives me the red bit, multiply by 2, that gives me the area of the shaded region. So that's how you do that. Okay? Now, the next question then was this one here, B, right? And this is very straightforward. Well, you're asked to show that DBC is an isosceles triangle. So that this here is an isosceles triangle. Okay. So I can start by saying as follows, right? I know that DB is equal to AD because C is the median, so it splits it in two. So AD has to equal BD. Okay? Now, I can also say as follows, right? Now, DE splits that there. Okay? That triangle there. So therefore, AE and EC are the same. That's 90 degrees, 90 degrees, and ED. So the triangle ADE and CDE are equal. And so that means AD must equal DC. So if AD is equal to DB and DC is equal to DB, then it's an isosceles triangle. So that's how you work that out. So it's fairly straightforward. It's just a matter of seeing it. And as you practice proofs, these become very easy. Okay? And then the other one was, given that the area of EDC, so EDC is 5. So if that's 5, that has to be 5. And if that splits as the median, that means that's going to be the same because it's splitting it in 2. So basically, that's going to be equal to 10. That's how you do that. Okay, hope that was helpful.